production, transportation, transmission of hydrogen energy, extraction. Pure hydrogen does not occur naturally. Hydrogen is not a basic energy resource. We should use another energy resource in order to get a hydrogen. So here it must be supplied by using some other basic energy resource to generate a hydrogen from water or other hydrogen containing chemical compounds. We should use another energy resources to get the hydrogen. Here processing, steam reforming. In steam reforming, CnHm plus NH2O, that output is NCO plus 2N plus M whole bracket into S2 divided by 2. High temperature steam separates hydrogen from the carbon atom in the methane. So for example, CH4, okay, from the methane hydrogen is separated. High temperature steam separates hydrogen from the carbon atoms in methane. So here carbon atom is separated, only the hydrogen, that is S2, we get. The hydrogen produced by this method is not used as a fuel but for industrial processes. This is the most cost-effective way to produce hydrogen today. Second is partial oxidation of hydrocarbon. CnHm, SO2 and H2O, that is output CO, H2 and H2S. Hydrogen sulfide. This reaction may be extended to produce a additional hydrogen. This is a partial oxidation of hydrocarbon. Next is the third is electrolysis. Electrolysis split water, that is hydrogen and oxygen. It involves passing an electric current through water to separate the atoms. For example, that is 2H2O plus electricity equals to 2H2 plus O2. So here electrolysis, water is split into hydrogen and oxygen. Hydrogen collects at the cathode and oxygen at the anode. You can see here hydrogen at the cathode and oxygen at the anode. Today hydrogen from electrolysis is 10 times more costly than natural gas. Today hydrogen from electrolysis is 10 times more costly than natural gas. Hydrogen collects at the cathode and oxygen at the anode. Today hydrogen from electrolysis is 10 times more costly than natural gas and 3 times more costly than gasoline per BTU. 2Na plus H2O plus 2E, that is output is 2NaOH plus H2. 2OH minus, that reaction we get is half O2 plus 2E. Coal, steam, oxygen. This process involves coal gasification to a syngas followed by conversion to hydrogen. Coal, steam, oxygen. This process is involved coal gasification to a syngas followed by conversion to hydrogen. Next is a steam iron process. Here steam converts a mixture of 5% of iron and 95% of iron oxide to 80% magnetite and 20% FeO4 dioxide. 5% iron, 95% iron oxide to 80% magnetite and 20% dioxide. Fe3O4, that is magnetite Fe3O4 plus 4 CO carbon monoxide, output 3 Fe iron plus 4 CO2 carbon dioxide. Here H2O plus 3 FeO. Reaction output we get H2 plus Fe3O4. Fe3O4 plus 4CO. Output we get 3Fe plus 4CO2. Same this one. Okay, same. Fe3O4 plus only carbon monoxide. Here 4 times is there. Here only carbon monoxide. Output we get 3FeO plus CO2. Here iron oxide plus carbon dioxide. Next is a nuclear heat steam coal, similar to coal steam oxygen. Here what we have in fourth process, coal steam oxygen. Coal gasification we do, and from that we get output syngas, and followed by some other process, and that we get a output is hydrogen. Here nuclear heat steam coal, same process similar to coal steam oxygen process, except the heat is supplied by a loop from a nuclear reactor. Heat is supplied by a loop from a nuclear reactor into the gasifier unit instead of oxygen feed to burn some of the coal. Emerging technologies. Photoelectrolysis uses sunlight to split water molecules into its components. A semiconductor absorbs the energy from the sun and acts as an electrode to separate the water molecules. Photoelectrolysis uses sunlight to split water molecules into its components. A semiconductor absorbs the energy from the sun and acts as an electrode to separate the water molecules. Biomass gasification. Wood chips and agricultural waste are superheated until they turn into hydrogen and other gases. Next is the transportation and transmission. Hydrogen can be transported in liquid or gaseous form. The movement of a gas by pipeline is one of the cheapest way of moving energy. Pipelines are clearly an attractive method of transportation of energy. So it can be transported either in liquid or gaseous form, and the cheapest method is through the pipeline. The movement of gas by pipeline is one of the cheapest way of moving energy. Here liquid hydrogen is useful as a fuel for aircraft and rockets. Liquid hydrogen is useful as a fuel for aircraft and rockets. Hydrogen stored in steel cylinder. Hydrogen stored in a steel cylinders at elevated pressure of approximately 125 atmospheric pressure. Hydrogen may be the perfect carrier for this energy. It can store the energy and distribute it wherever it is needed.